Hello everyone. So how many people are there with me? So yeah, welcome everyone. If I'm properly audible and visible, can you please write the same in the chat box so that I can begin? Let us wait for a few more minutes for other people to arrive. So whoever are present in the stream right now, can you just mention that my voice is properly audible and my video is also very clear? I'm properly audible and visible. Hello Shubham. Hello Shubham, how are you? Thank you Shubham for confirmation. So let us wait for a few more minutes and after that we will start. So let us. Okay, you are good. Hello Sachin, welcome. Today is the day 27th of our 30-day streak of solving SDE sheet. So did you all attend the yesterday's session? Why are you not posting homework questions on Discord channel? Okay, Shubham, I'm really sorry about that. I will be posting the homework question for yesterday's as well as today's on the description itself, on the description of the video. Okay, so you can solve those questions. You have more 3 days left for this 30-day streak. Hmm. And moreover, the problems that I will be posting will be of good quality and you can solve it. Okay. So we have 7 people with me right now. Yeah, I would request all of you to kindly invite your friends as well so that you all can study together in this session. And I have chosen three very interesting problems for today's session, and I will be telling you in just a few minutes. Let everyone arrive. Okay, so we have 10 people with me right now. And so, do you all want me to begin, or should I wait for 2 more minutes? Okay, I guess we have enough people. We have 12 people. Yeah. So, can you please mark your attendance in the chat box? Okay, so now I am sharing my screen. Yeah. And one more request to all of you is that kindly keep this session interactive so that I receive a good feedback from you all and it will encourage me to provide good quality content and at the same time improve myself. Okay. Hello, Naikaj, welcome. I see that Naikaj is one of the students who are regularly attending from day one, and that's very good. And meantime, the students who are new to this channel, we come daily live for SD Sheets streaming and at 10 p.m. And we have already completed 27 days. So what you can do is go to the GFG channel. You can subscribe to the channel and you will find all the recordings there. So basically, watching all those recordings, you will be solving around 180 SDE sheet problems, and these problems are extremely important from interview point of view. So basically, this will help you get prepared for your next interviews. Okay. So Naikas, I hope 13 people are with me right now, and we should start. Where is homework problem? I will update it after the stream. Okay. I did not get the time to select the problems, but I will surely update it after the stream. Okay. So let us start. First of all, I welcome everyone present here to the day 27 of the SG Sheet streaming. And my name is Gaurav Kumar Shah, and and I'm in my third year of BTech at IIT Kharagpur. Okay. So are you guys in your second year or third year? Okay. So let us begin then. Yeah. So as usual, let me tell the agenda of today's streaming. So the agenda is exactly the same as the previous streaming. We will be discussing three problems. Okay. So the first problem that we will be discussing will be bit difference. Bit difference. Okay, this is an easy category problem and this involves the concept of bits manipulation. The second problem that we will discuss is in order traversal. We will discuss both the recursion as well as the iteration part, and this is a easy to medium level problem. And this is involves the concept of tree data structure. And finally, the third problem that we will discuss is Fibonacci number. Okay, so this will highlight the concept of what are Fibonacci numbers, and we will be seeing a greedy strategy of solving it. Okay, so so this is a simple problem. Okay, this can also be put into easy category problem. So three problems: the first involving bits, the second is tree, and third a greedy strategy, array type of problem. So three very different problems from each other we will be discussing. So Sachin is saying he's in third year. Saivara is saying in third year. Vibha is also in third year. Okay, that's very well, and I hope you all perform extremely well in your upcoming interviews, and all the best for your preparation. So let us start with the solving. Okay, let me choose background. Yeah. So is everyone with me? We have 11 people with me right now. Okay, so let us start then. Hmm. So the first problem statement is that just a minute. I was open. The part was open. Yeah. Let's look into the problem statement. So the problem statement in the first part is says that we have been given two numbers a and b. Okay. So first of all, can you everyone tell me, are you all comfortable in English, or should I include Hindi also? Because someone in yesterday's streaming requested me to speak in a combination of Hindi and English, so that's why I'm asking. Hello, Miskat, Uddin, welcome. Comfortable in English. Sachin is comfortable in English. Okay, Sachin, no worries. So let us begin that. Yes. Okay, sure. English. Okay. Viva is also English. Okay, so let's start then. Okay, so the question says the task is to count the number of bits needed to be flipped to convert A to B. Okay, so what does this mean? It means that we have been given two numbers. The first number will have a binary representation, and the second number will also have a binary representation. And we have to check from the rightmost starting from the rightmost index whether they are equal or not. If they are if they are not equal, we will just count. So basically, what we need to do is convert one number into the other number. So if you want to convert one number into the other number, it means that at all positions its bits must be equal. Now, if they are unequal, it means that we have to change it, right? So that is the question. It is asking that we have to find the count of the number of bits that needs to be flipped to convert A to B. Okay. So let us look into it. Okay. So the question is bits flip. Hmm. Okay, or bit difference, whatever. So in the statement it is saying a is equal to 10 and b is equal to 20. Okay, so a is equal to 10 and b is equal to 20. Hmm. So 10 can be represented as 0 1 0 1 0, 0 1 0 1 0, and 20 can be represented as 1 0 100. So the question is asking me to convert A to B, and how many bits? How many bits do we have to flip? So if I want to convert A to B, all the bits in every position should be same. All the position, that is all the bits in every position of B should be same as that of A. So I start from A. So I see the 0th index. I see both are equal. It means I don't have to flip. But I see at the second point, we got 1 here and 0 here. It means that I need to flip the bit at the first index. Similarly, at the second index also I need to flip from 0 to 1. Third index I need to make it from 1 to 0. And fourth index I need to make from 0 to 1. So total number of flips, total number of flips needed to convert A to B is equal to 4 in this case. So therefore, my answer will be 4. Did everyone understood it? Can I have a +1 in the chat? Hello Priyabrata, you are in final year. That's very good. Hello Adarsh, welcome to the day 27. Hmm. Yeah, so I hope everyone got it. Just a minute, let me just switch on the streaming in my mobile as well, so that I can look into your comments without changing my screen. Give me a minute. Changing my screen. Okay, thanks. Yeah. So Naikaj understood it. Demba also understood it. Priyabrata also understood it. Sachin Yadav, Vibha, Shubham. Okay, that's very well. You all understood it. Now, understanding is not the issue here. Okay. Now, what do we have to do here is that write a code implementation of the same problem. Okay. So, how are we going to do it? So, what exactly is the concept? So, how we will implement in the form of a code? Let's see. So, we had 10, we had 20. Okay. So, 10 can be represented in the form of 0, 1, 0, 1, 0. Okay. 0 1 0 1 0, and 1 can be represented and 20 can be represented as 10 1 0 0. 10 1 0 0. Okay, so this was my 10 and this was my 20. Now what do we have to count here? We have to count only those bits, only those bits which are different at each positions, at each positions. Did you all get it? Because the number of bits which are different at each position in both A and B is the answer that will be needed to convert A to B. That is, it is the equal to the number of times we need to flip so that A gets converted into B. Okay. So we see that at this position it is different, at this position it is different, at this position it is different, at this position it is different. So answer is 4. Now, in order to get these two values, that is, how many bits are different and at what position, we need to do two things. The first is check whether they are same or not, whether they are same or not. And next is we have to traverse. Okay, so when we are standing at the 0th index, we are checking that yes, both are same or not. If it is same, then we will do nothing. But if it is not same, in that case we will do count plus plus. But after the 0th index get over, we need to go to the first index. Okay, right? So we need to do a traversing technique also. So these two concepts of bit manipulation will be used to solve this problem. I hope you all got it. Hmm. So Uddin is saying that one bit right shift, then and with one, if both the numbers are equal, then no flip. If not, flip. That's yes, that is exactly the concept to solve this problem. Okay. Yeah. So the first concept. So how exactly are we going to check whether it is set or not? Okay. How exactly are we going to check? So Uddin said in the chat box that we can do an AND operation and we can finally get that whether they are equal or not, right? Hmm. So that is a valid way. Okay. So, but what I want you all to do is think a little bit different. Okay. We can also check that if they are equal or not. Okay. So what we can do here basically, let's say with the help of right shift operator, we check whether both are equal or not. We see whether this is set or this is not set. So once we get this value, then we just do a right shift and just decrease all of this operation and keep a count variable to do a count plus plus. This is okay. But I want to discuss a new concept because in the last few streamings I have been discussing the right shift operator a lot of times. But I want you to discuss solve this problem without using right shift operator. Okay, without using right shift operator. How will you do it? Anyone? So and then right shift bit is used. Okay, yes, Adarsh, I understood that you were trying to say that we can do an and then a right shift. But I don't want you to use this concept. This is we have been discussing similar type of problem in previous stream. I want you to use a new concept. Naika is saying that Zor, if equal then Zor gives 0. Okay, and Adarsh is also saying Zor. Okay, yes, I agree that somehow we have to use the concept of Zor. But how? They, Zor and count number of ones. Okay, Uddin is saying Zor and then count number of ones. Okay, Uddin, let's try out this concept. So basically, let me discuss the properties of Zor now. Okay, so properties of XOR, what exactly a XOR means? So let's say if I write A and B, so I'm writing truth table. If both the bits are 0, XOR will be 0. If one of them is 1, XOR will be 1. Okay. Hmm. Uh, if one of them is 1, XOR will be equal to 1. Okay, and if both are 1, XOR will be equal to 0. So XOR is basically a very interesting and a good test to check whether if either of them is 1 or not. Okay, so when will XOR will give 0? So XOR only gives 0 if both the bits are same. So XOR of any two numbers will be equal to 0 when both the numbers are same. Both the numbers are same. Okay. Hmm. So basically, let's say, how can we apply this concept of XOR? Both are different. One तभी होगा जब both are different. Yes, you are right. XOR करेंगे and then we will count the number of one. तो अगर लेट्स से अगर यहाँ पर बोला जा रहा था कि अगर मेरे पास A और B है तो मुझे पता करना है कि किस पोजीशन इन व्हाट पोजीशन बोथ द बिट्स आर डिफरेंट. ओके. So अगर let's say same है bits, so XOR will give me 0. But if the bits are not same, in that case I will get as 1. Okay. And what do we have to find? We have to find the number of bits that are different. The number of bits that are different. Okay. So what we will do? We will the first step is to XOR both the numbers. We have A and B. So what we will do? We will XOR both the numbers, and after this we will get a new number, and we will just count the number of set bits in this new number, and finally we will able to get our answer. Okay. Brain, or I'll go to count set bit. Okay, chalo. So let's say, so we will do take a variable answer is equal to A or B, and after that what we will do, we will then count it. Okay, so let's implement in coding part. Okay, sorry, I'm writing the code part, and if you have any doubt, we will see. Okay, so let me write. Uh, hmm. I hope everyone is understanding it. If you have any doubts, you can just write in the chat box. Okay. So let's say first what I take here, I take a value called answer and I initialize it with 0. Okay. After that, what I do here is equal to answer is equal to A or B. Okay. I do an answer. Now, what we have to do is count the number of set bits in answer. So let me take a new variable result, and let me create a new function. Okay. And the name of this function will be equal to int, let's say, count set bits. Count set bits. This will accept a number n. Okay. So this will accept a number n, and it will return whether that number is basically the count of the set bits. So let's see unt count set bits. Okay. Count set bits. Now after that I will pass answer to this function, and after that I will return res. Okay. So this is done. Now we have to implement this function. Okay. So let us see how we are going to implement this function. So basically, let's say we declare a new variable called count, cnt is equal to 0. And what do we do here is that we first check whether that bit is 1 or not, and we traverse. So what we can do here is we run a while loop, and traversal technique can be implemented using the concept of right shift operator. Okay, so what we do here is that we write a while n, and finally we check, and we do basically a count plus equal to n and 1. So what is this? So n and 1 will return 1 if it is a set bit, and it will add 1 to the count, and that is my answer because I want to count the number of set bits present in my integer n. And after that, what will I do? I will do a right shift. So n is equal to n right shift 1. Okay, so this is done. And finally, I will return count. Okay, finally I will return count. Okay, so let us execute this code and check. Yeah, it's efficient algorithm login. Answer is equal to answer n minus 1. Okay. So basically, as you can see, all the test cases are passed, and we have successfully solved this problem. So let us discuss the time complexity and the space complexity of the problem. Okay. So what can we do here? So basically, the first involved was writing a XOR. So this is just a constant time operation. So this will not take any time. After that, we had to implement a function to count the number of set bits, and we were using a while loop. And at every iteration, we were decreasing the bits by 1 by doing right shift. So we know that any integer value will have at most 32 bits. So basically, that is nothing but log of highest value of integer. So the time complexity of this operation is O of log n, and the space complexity is equal to O of 1. We are not using any extra space to solve the problem. Okay. Explain while loop block once. Okay. Okay, yeah. So what exactly was that while loop doing? The while loop was counting the number of set bits. Okay. I passed a function. I created a function. I passed a value n, and that with the help of the while loop, I'm counting the number of set bits in n. how exactly it is counted, I'm showing you. Hmm. So basically what happens is that, uh, let's say this is my number 100001001. So the first bit is basically the 0th index bit, and what I'm doing an AND with 1. If I get as AND 1, so it means that this bit is set bit, because 1 and 1 is equal to 1. So if I do a n and 1, if this returns me 1, it means that last bit, that is the least significant bit, is a set bit. So what I'm doing, I'm just incrementing my count with this value. If this value is 1, count will get incremented to 1. It means that position is a set bit. The lowest significant bit is a set bit. And if it is 0, then count will not get increased, because 0 is nothing. Okay. So basically, in that way, we are increasing the count. After that, what do we have to do? This was basically checking whether it is a set bit or not in the lowest significant bit, okay, least significant bit, LSB. But now I want to check to the next bit. The next, what I can do here is that I can do a right shift operation and right shift one. So this will just throw away the last bit. So if I do a right shift operation with this bit will get thrown away, and this will become a least significant bit. Again, I will do the check with this bit, and again I will proceed with this bit. After that, just doing a right shift means I'm throwing away the last bit, and the second last bit becomes the least significant bit. Okay, yeah. Thank you, Vara. I hope everyone understood it. So the time complexity has been discussed and space complexity is also discussed. So now let us solve the next problem, that is in order traversal of a problem. Okay. How many of you all know about this in order traversal? Okay. So this problem involves binary tree. Hmm. So binary tree is a data structure. Okay. And tree data structure is a kind of a hierarchical data structure. Okay, I hope everyone knows this. Everyone knows that array is a type of linear data structure, and after that, graphs are a kind of hierarchical data structure. Tree is also a kind of hierarchical data structure. Okay, so basically, it means that we can represent data in the form of a hierarchy. Okay, everyone got it? Chalo. We have 16 people with me right now, and I want you all to everyone to stay with me, because I will be discussing two very interesting problems, and it will be much helpful in many of your interviews and preparation journey. Okay, so now we have been asked to write the in order traversal of a given binary tree. So what exactly is a binary tree? A binary tree contains a root and two nodes. Okay, and if this is a root, this will also contain two nodes. This will also contain two nodes. This will also contain two nodes, and this will also contain two nodes. This is the root node, and every other node is basically the child of this root node. And the nodes that have both the child as null are called the leaf nodes. Okay, and every node will have two child. Okay, every node will have two child. Every node will have two child. So this is a binary tree, and we have to do an in-order traversal. So in-order is basically a traversal technique. What is it? It is a traversal technique. Hmm. Okay, so now I will define what exactly is an in-order traversal. I am assuming everyone knows about tree data structure, so I'm not going into very deep into explaining it. I'm going to solve the concept of the problem. Let's see. So basically, uh, hello Sneha, welcome to today's streaming. Let's see. Hmm. So basically, after that, so the definition of in-order traversal. Hmm. So how many of you all know about other forms of traversal? Can you please write in the chat box all other forms of traversal that you know? Yeah. Hmm. Level order. Okay. Level order. Okay. So let me tell you some of the in order pre-order. We have got in order, we have got pre-order, we got post order, we got level order, we got Morris order, we got diagonal order, we got zigzag order. So there are many. You can see there are many different ways of traversal a tree can have. So all of these traversal techniques are very important from interview point of view. You must know how to solve this using recursion, using iteration, everything. Okay, but in this in this streaming session, we will be discussing only the in-order traversal. Okay, so these are not important from today's streaming point of view. So let me wrap this. Hmm. So let's start. So basically, in order traversal means that. Hmm. So in order traversal means that first we have to go to the left. then we have to write the root, and then we have to write the right. Okay, as I said, a tree data structure is represented in this fashion. So let me create a tree first. So this is a tree. Hmm. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, hmm. This is 7, and after that this is 8, this is 9, and this is 10. So I have created a tree. So 1 is the root of my tree, 2 and 3 are its child, 2 has child as 4 and 5, 5 has a child as 6, 7 has no child, so 7 is a leaf node, 3 has child as 7 and 8, 8 has child as 9 and 10. Okay, and these are the leaf nodes. Okay, now we have to do a inner traversal. Now we know that this child is called the left child and this child is called the right side. So basically, a node of a tree is represented using a structure with the help of three things. It has a value, and it has a pointer to its left child, and it has a pointer to its right child. Okay, so these three things are there inside a node. That is a reference of a node. Okay, so basically inner traversal means that first we will write the left part and then we will write its root, and after then we will go to the right part. So basically, let's say we come to this root, we go to its left part 2, but 2 also has a left part, we come to left part 4. Okay, so we basically print 4 because 4 doesn't have a left part. Okay, and the root will be 4. Now after we want to go to right, but we see that there are no right side. Okay, so it will return, it will come to 2. Okay, now it will print 2 because we want to print root. After that it will go to right, after that it will go to right, and it will come to 5. 5 will try to go to its left and it will come to 6, so it will print 6. Okay, now 6 will again try to go to its left, but it will not be able to, so that is why it is printing 6. After then it will go to right, but it could not go because it is null. It will return to 5, this will return to 2, this will return to 1. So finally I will print 1 because after left I am supposed to print 1. Now I will go to right. Okay, so I will print 3 now. Okay, so 1 is done, so I will go to 3, but again 3 will also go to its left, that is 7, and finally 7 sees that it doesn't have any child, so it will print 7. Similarly, after 7, it will come back to 3 and it will print 3. Okay, and now 3 will go to its right, 8 will go to its left, that is 9. So 9 will again get printed. After it will come at 8, and finally it will go to 10 and it will print 10. Okay, so this is the in order traversal, and you have to return this in the form of an array. Okay, as you can see in the problem, we have been given the root of our tree and we have to return a vector containing the in order traversal of our tree. Okay, so how exactly are we going to do it? Let's see the comments. Post traversal. Hmm. I hope everyone is understanding it. Hmm. Hello Satendra, hello Shuman, hello Chaman. Let's So how exactly are we going to do? So basically, what happens here is that there are two. The first thing we can do is equal to apply the concept of recursion. As we were saying that we have to repeatedly go down in its left, keep on going down in its left until and unless we find a null. And after we find a null, we have to go back to its root and then traverse its right. So this entire idea can be modeled as a recursion, as a recursion. Okay, I hope you all understood it. So how exactly we will solve this? Let us see. So what all we can do is we can create a function that accepts the root. Then what we can do, we can just recursively call this function for the left part of our root. So root of left. After that, what we can do, since this is a recursive function, it will keep on going to its left. Okay, and the base condition will be as long as this root is equal to null, or in fact, let me write as node. Okay, because node. So if node is equal to null, in that case I will return. If not, then I will keep on going. So once it reaches once it reaches null, I am supposed to print because after left comes the root. So now I will print. What I will print? I will print just the value. Okay. And after I print the value, I am supposed to recursively go to the right part. Yeah, and keep on going to the right part until and unless I find a node. So I will go to node of right. Got it? Can I have a plus one in the chat? Those who have understood this concept. So this is just a simple in order traversal recursive approach. So let me write the code using iterative approach. Yes, I will discuss iterative approach as well. So let me write the recursive approach. Hmm. So first thing is equal to, we have to check if hmm. So let me create a new function. uh, okay. So what I'm doing is, let me create a new global variable called ans. Okay. And let me write a new function, hmm, void in order. Okay. And this will basically take a node. Okay. Now the first condition is equal to, if node is equal to null. Okay. If node is equal to null, in that case we will just return. If not, we will recursively call this function in order and send the left part. Okay. After we send the left part, we are supposed to print. So I will just store that value in a answer vector. Okay. Hmm. And this will be equal to node of val. And finally, I will again call the function in order recursively for the right child. Okay. So this is done. And after this function gets executed completely, you can have our answer. So we just return ans. And before that, let me uh, let me call this function in order with the root. Okay. So let's compile and see. Hmm. Okay. There is a value. It is saying that a struct has known member name is val. Acha, okay. As you can see in Geeks for Geeks platform, the value of a node is represented by data. So I'm supposed to write data. Okay. Recursive node data line 44 node data. We can do the recursion in order function. Yes, we can do. But just to explain you the concept very well, I just try to write a different function. Okay, it's easier to understand and to see the implementation of how we are storing it in a global variable answer. Okay, so this problem is also solved. Can I have a +1 in the chat? Those who understood it. Now I will be discussing the yeah. Hello, Ashish. Hello, Adarsh. Hello, Adarsh. Hello. Okay, so let's discuss the iterative approach. So, why exactly are we supposed to discuss the iterative approach? Can anyone say? So recursion से तो काम चल गया. So recursion was actually helpful in solving the problem, but why iterative? How it is helping? Anyone? Okay, Naikach, that's very good. BV Nandan, welcome. Hmm. Can anyone tell me? Can anyone tell me? Space complexity. So Adarsh is saying space complexity. It's more efficient in space. That's yes, that is the answer. So basically, recursion. Whenever we are applying the concept of recursion, it basically means that we have to use the recursive stack space. Okay, so every computer has a memory in it, and that memory is basically needed to create a recursion stack space. And with when we are calling a recursive function, it goes a recursive function means that a function is calling itself. So if it is calling itself, it needs some kind of storage to store that particular entities. So that is why a stack space is needed. And it is called auxiliary stack space. So we need to use an idea of iteration. But basically, the idea of iteration will involve me using an extra space only. Okay. So basically, what I will do, I will model the recursive idea in the form of an iteration with the help of taking extra space. And since recursive stack space is basically the data structure, nothing but stack only. Okay, the implementation of the recursive stack space inside a computer memory is similar to the data structure of stack. Okay, so stack is basically a first in last out kind of data structure. So basically, what happens? Whatever element goes in, it will keep on going in. So the element which was entering in the last will come out first. So it is equal to first in last time, philo. First in, it will last in. Okay, so that is the kind of data structure stack is. Now we have to implement that using. So what we were seeing here is that basically we were calling a recursive function f. We were going to its left child, we were going to its right child, and if it after going to its left child, if it was null, we were just printing its value. So we have to just implement these three steps. So what can we do? No, Naika, you are saying that no benefits. No, it's not like that. Recursion stack space basically involves using computer memory. Okay, it involves using RAM. So that understanding these concepts will take you to understanding the architecture of computer, which is beyond the scope of discussion. Okay, and in interviews, the iteration is the most preferred form of solution to this code, and not the recursive one. Okay, so let's start. So as I said, we have to take three steps. The first is going to its left. The second is writing the val. The third is writing its right. Hmm. Okay, so these are three steps needed to model this problem. Okay. Hmm. We have benefits like that. Yes, others we have. Hmm. So let us see this. Hmm. So basically, how we will do it. So what we will do, we will declare a stack. Just like we will declare a stack, and what we will do, we will run a while loop. Okay, and this while loop will run. Now we will check whether my node is not equal to null or not. Okay, so I will check this value. What we were doing, we were recursively calling the left part until and unless we reached a null. So we will check whether node is not equal to null or not. If it is not equal to null, what we will do, we will just push the value of node. Okay, push the value of node into the stack, which means that if I'm standing on a tree, I push it into the value of side, then go to its left. Again, push it in the value of side, go to the left one. So basically, I'm pushing it in stack. That is recursion. What happens in recursion? We recursively call this function, and this entire thing gets pushed into the recursive stack space. Similarly, we'll push it into recursive our external stack space that we created. So st.push, we will push the val. Okay, and after we push the val, we will just go to its left part. Node is equal to node of left. So this is the first step that we can do. Okay, I hope everyone understood it. So after I have done this, now what exactly it remains? Okay, so let me write it properly. This is our while loop, and if node is not equal to null, in that case, what we will do, we will just write st.push the node of val, and after that we will do node is equal to node of left. Okay, keep on traveling to its until unless you find it. But let's say we found a null. So what we will do now? We will print its value. So what can we do here is that so we create an answer vector and we push that answer vector answer dot push back node of val because we have reached null. So we basically must need to put it right. But after we put it, we need to move it to node of right. Okay, so this is seems to be the concept, but we have missed few things here. Okay, now what let it may happen that let's say the stack has become empty. So what will happen if I keep on moving into the array and I find the stack has become empty? So we have to put a condition that if the stack become empty, okay, in that case what we will do, we will just break out of our loop because we know that we are our traversal is complete. Okay, but if the stack is not empty, in that case what will I do? I will take the top element of the stack. Okay, and I will put node is equal to sc.top and I will pop that element and then I will put it in the node. Okay, because when I am recursively going into the step, this first this was element put, this element was put, this element was put, this element was put. Now I need to remove this element before printing. So I am printing this element and at the same time I need to remove the element as well because I need to free my stack space so that I can move to the next part of the tree. So whatever will I do? I will store it in a external variable node and I will push that node value of the node into this and I will also just remove st.pop also. I will do st.pop here as well. Okay, so this was the entire concept of in-order traversal, iterative in-order traversal. Okay, so let me write the code. Did everyone understood the concept? Okay, then we reach the end and then we have to fetch value from stack and not getting empty. Yes. Okay, so let's start writing the coding part. Hmm. So as you all can see, this is the basically. Hmm. Okay. Okay, so let me write the code. Yeah, the iterative code. Hmm. We have 10 people with me right now. I want all of you all to stay with me. So let's say we create a stack. Okay. Now the what we are storing is basically we are storing the nodes. Okay. So the data type of stack will be node, and the name of our stack is st. Good. Well and good. After that, we will declare a new node. Node star node is equal to root. Okay. After that, we will declare a vector to store the answer. Ans. Okay. Now we will run a while loop. This while loop will run infinitely, but we will have a breaking condition as well. Okay, which will put inside the loop. Now first we will check whether the node kindly excuse me, whether the node is not equal to null or not. Hmm. So if it is not equal to null, what will I do? I will just push it into the stack. So st dot push is equal to node. Okay, and after that, what will I do? I will do node is equal to node of left. Hmm. Move to its left part. Then now let's say if it is null. In that case, what I need to do? I need to print the top element of the array. So I declare a new variable node. Okay, so node basically contains my variable. I will write the top element of my node. After that, what will I do? I will do st.pop. Okay, and since I do st.pop, I need to push back into my answer as well because I need to print that. Okay, so I will do node of val. Now after I do node of val, I need to move to its right. Hmm. So node is equal to node of right. But before writing this condition, one important thing is check. It may happen that my stack has become empty. If st dot size is equal to 0, okay, it means that the stack has become empty. In that case, I will just break because my traversal is complete. It means because there are no elements in that stack. So there will no elements in the stack means there are no top elements. So what will it print? It will print nothing. And if I do not do this check, then this loop will run infinitely and segmentation fault will come. That is why this check was necessary here. Okay, so after this while loop gets over, my answer, the inordinate traversal, is contained in the data structure answer, and finally we will return that answer. Okay, so let's submit this code and see. While st is not equal to empty, yeah, we can do it, but it's better to check here. Okay, so let's say data. Okay, so let's move. I hope everyone understood it. As you can see, all the test cases have successfully passed, and we have solved this problem. Hmm. Okay, so let's move to the next problem. Yeah. Did everyone understood it? Can I have a +1 in the chat? Those who have understood it, so that we can move to the next interesting problem. Hello Naikaj, hello Adarsh, hello Jyoti. It will have same complexity as previous, yes. Can I see the code again? Yes, you can see the code again. Just have a look. Yeah. So it will have the same complexity as previous. Let me discuss the space and time complexity. The time complexity will be same, but the space complexity, since it is iteration, we are not taking any extra stack space. Okay. So that is the important part here. Naika's connection is lost. I don't think so. I have a pretty good Wi-Fi today. Can everyone listen to me and see my screen and my am I audible and visible properly? Can anyone confirm? Yeah. So Naikach, are you done? Okay, okay, okay. Okay, yes, everything is fine from my end. So Naikach, it may seem that you have. Okay, sure, sure. No worries, no worries. Let us continue. Hmm. Yeah. So this problem is done. Okay, Naikach, let's continue with our third problem. So third problem is kind of very interesting as well. So okay, let us not look at the solution. Okay, that was for me. Okay, so basically, the third problem says that we have been given a number n, and we have to find the first n Fibonacci numbers. Okay, so the first two numbers are series are 1 and 1. Okay, so how exactly are we going to solve this? So does everyone know the concept of Fibonacci numbers? So what are Fibonacci numbers? First, we have to see it. So basically, Fibonacci number is a special type of a series. Okay, special series. Hmm. Where the first two numbers are always 1, and all the numbers after the first two numbers are basically the sum of the previous two numbers. Okay, so the third number will be the sum of previous two, that is 2. Fourth number will be 2 plus 1 equal to 3. Fifth number will be 3 plus 2 5, then 8. then 8 plus 5 13, then 13 plus 5 21. So this is there. Now we have been given n, and we have to print the first in Fibonacci numbers. So if we have been given n equal to 1, we will print 1. If we have been given n equal to 5, we will print 1 1 2 3 5. The first in Fibonacci numbers. Okay, Fibonacci numbers. Okay, it's pronounced as Fibonacci and not Fibonacci. Okay, Fibonacci numbers. So how exactly are we going to do it? Let's see. Okay, so in the question, it is given that our task is to implement a O of n kind of time complexity, and without taking and yes, we are allowed to take a extra space complexity of big O of n. And the constraint, it is mentioned that n is of from 1 to 84. Okay, so how exactly are we going to take? Let's see. Hmm. Okay, so let us see. Hmm. So first of all, let us create a vector, because we have to return a vector, and it is already by default a long long. So we'll create a vector answer. After that, because this is a vector, this is a data structure in which I will store my answer, the first n Fibonacci numbers. Now the first condition. Okay, so let me explain it to you. So in the question, it is given if n is equal to 1, and if n is equal to 2, I will print 1 in this case, and I will print 1 in 1 in this case. So basically the first two Fibonacci numbers are fixed. So there are no concept or no formulas. The first two Fibonacci numbers are always fixed. So we have to implement the same in the code as well. Okay, so let me just write the code at the same time. Okay, because it's pretty standard and pretty implementation based. Okay, so if n is equal to 1, if n is equal to 1, what can I do here is that answer dot pushback. Okay, answer dot pushback is equal to 1. I just push back 1. And if let's say now I have to check if n is equal to 2. If in that case, I will be pushing back 1 and again a 1. So it's better I do something like this. If n is greater than or equal to 1, I do a pushback of 1, and I again check if n is greater than or equal to 2. So in this, by implementing in this fashion, I'm just covering both of the cases. Okay, so this will again be equal to 1. Got it? If n is equal to 1, if n is greater than equal to 1, it means that I will push back 1. If n is greater than equal to 2, it means that the first two, I need to print the first two elements. So now I will continue. Okay, so this will basically take care of the first two conditions. Did everyone understood it? Can I have a plus one in the chat? We can use simple loop. Yes, we definitely will use simple loop. Naika is saying f of n is equal to f of n minus 1 plus n minus 2. Yes, we can definitely use a recursive function if we want to know the nth Fibonacci numbers. But in this case, we want to print all the n Fibonacci numbers. Okay, the first n Fibonacci numbers and not the nth Fibonacci numbers. Okay, hmm. That's very great, Uddin. That's very great, Saivara. Okay. So yeah, so now I am done. Okay, so exactly now I need to move when the case of n is greater than equal to 2. So let's say if n is equal to 3, so what should I do? I have to add the previous two numbers. So in that case, what I can do is I can start from write a for loop, but this for loop will start from 2. Okay, because what exactly is happening, I already have filled the 0th index and the first index. Okay, because you see that in my data structure answer, okay, I already have filled the 0th index with 1 and the first index with 1. Now I have to start with the second index. That is this, index number 2. So, hmm, hmm. So this was the problem. I is equal to 2, I is less than n, and I plus plus. Okay, because our data structure is a vector, and vector follows zero based indexing method. Okay, now answer dot pushback. Okay, so answer dot pushback, what can we do? Hmm. Okay, so let's say I want to just take the previous two values. Okay, so let's say I declare two values, long long a is equal to 1 and long long b is equal to 1. Okay, now what I'm doing here is equal to, I'm just adding a plus b, because a and b are 1. So after the third number gets added, I need to replace my a and b also. Okay, so what will I do? I will declare a new variable called long long c, and this c will be nothing but equal to a plus b. And after that, what will I do? I will just I will just initialize the value of a equal to the value of b, that is a equal to b, that is I will put the value of b in a, because my a is no longer needed, and the value of new a will be nothing but the value of b, because we are shifting by one space. Okay, and my b will become c. Okay, A is equal to B and B is equal to C. So this is the entire concept. And finally, what we will do, we will return ANS. Okay, so let's submit this code and check. So did you all understood this concept? Okay, so there is a compilation error. Let me check the. Let me first block a spam account. Yeah. So let's say. So there is a small error, and I did not declare a function value I. Okay. Hmm. We have 16 people with me right now. Yeah. So as you can see, all the test cases have passed, and this problem is correct. So did you all understood that why exactly did we did that variable declaration part? We were looping from I equal to 2 to I is less than n, and what we were doing, we were storing a plus b. After that, what we were doing, we were declaring a new variable and storing the value of a plus b. So and after that, we were making a is equal to b and b is equal to c, because after I have added 1 and 1 equal to 2, now I need to make this 2 equal to 2. So this was my a b. I do not no longer need these values as my a and b. I need these two values as my a and b. So this was the old a and b. This was the new a and b. So the new value of a will be the old value of b, and the new value of b will be the old value of c, that is equal to a plus b. The old value of a plus b. Got it? Hmm. So that was the reason I did that declaration steps. Okay. I hope everyone is correct. Hmm. Okay, so the problem has been solved, and we have successfully solved, and all the test cases have passed. So this brings to the end of our session. We have solved three problems. Let me discuss the time complexity. The time complexity will be O of n, because we are doing a traversal, and we are also taking extra space that stores n numbers, because we need to print the first in Fibonacci numbers. So that is the space complexity is also n. Okay, we need two previous value. Yes, Naikach, very well. So let us. So do you guys have any doubts related to today? Any doubts? Hmm. Can explain n equal to 2 greater than, okay, okay, very well. So let's see, let me tell you, what if the value of n was equal to 1? If n was equal to 1, this condition would get executed, and these conditions won't get executed, and finally I will return 1. What if the value of n was equal to 2? Then this condition would get executed. I have pushed back 1. This condition would also get executed, because n is greater than equal to 2, and this condition won't have been executed, and I have written 1 and 1. What happens if n is equal to 3? If n is equal to 3, in this loop is starting from the second index. So who will fill the values of the first 0th index and the 1 index? So these two if statement will take care of it. So if n is equal to 3, will automatically satisfy both this condition. That is why I have written in this fashion. Okay. So if I would have written if n is equal to 1, and when n equal to 3, so I was not able to get into this for loop, right? जब n 3 होगा तो ये कंडीशन नहीं वैलिड हो सकता अगर n इक्वल टू 1 रहता, इसीलिए वी आर पुटिंग इट n ग्रेटर देन इक्वल टू 1. Okay, so Sai Vara Prashar, did you understood it? Hmm. So this basically makes sure that no of the edge cases are missed. Did you all understood this concept? In my case, it's showing segmentation fault. In your case, it is showing segmentation fault. It may be the reason because you may be starting from any other index from I equal to 2 or I equal to 1. If it may happen that you are doing less than equal to n, or you have declared integer variable, because we want to declare long variables. Okay, because the question has been test case has been set in that fashion. Okay, so finally we have reached to the end of the streaming. So today was the 27th day. So a huge congratulations to all of you who are watching this series from the starting and ending, everyone. So after the stream gets finished, you all can just type in the comment to mark your presence. Okay. So tomorrow will be the day 28th of the SDE sheet streaming, and I will be again be available tomorrow with three more problems. And meantime, everyone, I want you all to again attend tomorrow, and at the same time keep on practicing, because if you consistently practice it, you will definitely get better, and you will see improvement in your learning curve. Okay. So if any more questions, I will be here for 2 more minutes. Gaurav bro won't do the solution with DP approach. In the C. So what happens in DP approach is that we have to identify if there are overlapping subproblems. Okay. So let's say if the question was you have to print the nth Fibonacci number. Okay. If nth Fibonacci number was printed, so in that case, what happens here is that we write a recurrence relation as f of n is equal to f of n minus 1 plus f of n minus 2, right? So what happens that these functions are recursively called, and it may happen that there will be very a lot of overlapping subproblems. So we were using the concept of DP with memoization to decrease its time complexity and not make unnecessary recursions. Okay. So what you can do here is that move to the GFG platform and learn about this also. Okay. So I may take this problem tomorrow, the dynamic programming approach of Fibonacci numbers. Okay, because this is also an interesting problem, and if it has not been done earlier, I will check it and then I will take it. Okay. Good night, Naikaj. So we are almost to the end of the session, and I hope everyone keeps on practicing, and all the best to your preparations. Okay. So let's meet tomorrow. Bye bye.